First thing we need to do. What the heck is a negative exponent? What is a zero exponent? And how can we start to think about what this means? What can we use to think about this? And it turns out that when we fill in this table and we just start in the positives and go into the negatives, I think it'll become pretty clear to you. So let's use the calculator. 2 to the third. That's 8, so let's write that. 8. 2 squared we know is 4. I'm not going to use the calculator for that. 2 to the 1 is 2. All right? 2 to the 0. Now, I know what you're thinking. Well, first off, what does an exponent actually mean, right? This is 2 times 2 times 2. This is 2 times 2. This is just 2. How many 2's? 2 to the 0, that means we have 0 2's? How do we multiply 0 2's? This stuff gets to be a little confusing in some ways, but 2 to the 0 power, it equals 1. Now this is actually going to be true for every number. Any number to the 0 is going to be 1. So that's one of our new rules. Let me actually go ahead and write that as one of our new rules. Anything to the 0 power equals 1. Doesn't necessarily make a whole lot of sense if you think about it. There is a way to explain it. I think I'm going to save you the details. Just know that anything to the 0 is 1. To the 0 power is 1. All right, let's take 2 to the negative 1. 2 to the, oops, 2 up to the negative 1. 0.5. Let's write that for now. What about 2 to the negative 2? 2 up to the negative 2. 0.25, okay? So they're definitely decimals. What about 2 up to the negative 3? 0.125. Now the reason I'm taking you through this all is because hopefully you're starting to realize they're definitely fractions. They're getting smaller as they're going. This is a half, this is a fourth. And actually I'm going to write that like this. 1 over 2, 1 over 4, and 1 over 8. Now hopefully you're noticing something kind of interesting here. Maybe if I go like this, you'll see it here. Pick a different color. What do you notice about 2 to the 1 and 2 to the negative 1? 2 to the 1 is 2. 2 to the negative is 1 over 2. 2 to the 2 power, 2 squared is 4. 2 to the negative 2 is 1 over 4. Looks like you're just taking that number and putting it in the denominator, and that's basically what you're doing. This is the other rule, is we can also write this as 1 over 2 to the 1, right? You can also write this as 1 over 2 to the 2, and 1 over 2 to the 3. In order to make that negative exponent positive, you have to move it to the denominator. So what I mean is, you have something, I'll use an x this time. Actually, let me go ahead and use an x here as well. And then if you have x to the negative 3, in order to make it positive, you move it to the denominator. Now, what you're going to notice is it's not that you're always moving it to the denominator. If you have x to the negative 2 under 1, to make it positive, you move it to the numerator. So it's basically, if you have a negative exponent, it switches numerator or denominator. It crosses that line. Okay, so those are our two new rules, because when you put in the calculator, you start to notice they're fractions, and those fractions are just the reciprocal, basically. Now, it's not exactly the reciprocal, but you're moving it to the opposite place. If it's in the numerator, it goes to the denominator. If it's in the denominator, it goes to the numerator. Let's take a look at what that. So here's the first one, and it's the first one on the worksheet. I'm going to do it here first. Now, something to help you out is this. Every problem has a numerator and a denominator. Now, sure as heck doesn't look like it, but we can take anything and write it over 1, right? Okay. Now, there's no expanded version here. You can find a way to do it. Not with this, but I'll show you here in a second. So v squared and v to the negative 4. Now, you will never have an answer with a negative exponent in it, ever. Okay? So this is what I mean. We're going to take care of this negative exponent. How do we do that? Now, keep in mind, these are separate. V squared times v to the negative 4. So that v squared, it has no reason to move. It has a positive exponent. It's staying right where it is. But the negative, we need to make it positive. Your answer is never going to have a negative exponent. So that moves to the denominator and it becomes positive. Hey, there you go. So anytime you have a negative exponent, it switches to the numerator denominator. If it doesn't have it, it stays there. Okay, so the v squared stays there, v over 4. And then from there, just use your other rule. Cancel out two v's on the top. Cancel out two v's on the bottom. There are more v's in the bottom than in the top. So when we cancel, there will be v's left in the bottom. All of them we cancel at the top. Okay, so when it comes to this, first off, I would really like to see your work. So I think taking a picture of your work would be best for this stuff. Here's the other thing you can do. Insert, and this is what I'm talking about. So it's 1 over v squared, right? Now, a lot of you are going to want to do this. 1 over v squared. And honestly, I would take that. That doesn't look so bad. I'm okay with that. But check this out. Once you hit insert equation, go to this right here. It says math operations. Hit a over b. And it's 1. It's going to be small. Oops. 1 over v. I think you can make that bigger if you highlight it and make the font cool. Apparently not. So, dang. Okay. What if I do all of it? It helped. not what I was aiming to do. But there you go. 1 over v squared. So that is a way to do it. I think I'm going to take pictures of my work for the rest. Okay? So, because I'll be honest, I would really like to see your work for this stuff. Let's keep in mind the rule that we learned in the previous video, that this 3 is multiplied to the 4 and to the negative 1. Now, when I say multiply to the 4, that is a confusing way for me to say it. There's that exponent 1. You cannot multiply the exponent times a regular number. That doesn't make sense. Exponent times exponent. So 4 to the third, v to the negative 3. Then what you're going to do is we have a negative exponent. So I'm going to create a fraction. And that v to the negative 3 goes to the bottom. 4 over 3, it has no reason to move. It's separate from the v to the negative 3. It stays, but the v to the negative 3 goes to the bottom and it becomes positive. And that's all you can do. There's no canceling there because these are v's and these are 4s. If you want to do 4 to the third and start to get used to that, I'm cool with that. But either way, that's what we're looking at. Let me take a picture of the work for you. Those of you who still haven't caught on to that, image, insert, image, camera. See if I can get a good shot of it. And it's just the top line of work. I will crop that out. And that'll do it. Make it a little bit bigger. Maybe not. All right. All right, took a better picture of my work because that last picture was crap. All right. Next one. All right. Now, first off, you should hopefully notice that there's an m to the 0. And also, if you need to, separate everything by multiplication. As long as there's no pluses or minus, you can do that. Separate everything. So now just deal with, what I would say is let's take care of the negative and zero exponents. So the newest rules we have, let's take care of those. So this one, m to the 0 equals 1. I'm not even going to include it because 4 times 1 is 4. 1 times anything is just itself. So what we have left, next step, 4 times n to the negative 3 over 2 times n to the third. Pick a different color. The n to the negative 3 needs to move to the bottom. Now, the negative exponent, there's no switching. All you're doing is moving the base and the exponent with the negative exponent. So there you go. So 4 stays where it is. It's separate. 2 times n to the third and our brand new n to the third on the bottom. Now, let's do 4 divided by 2. 4 over 2 is 2. That goes on top. And then let's add these. 3 plus 3. We're multiplying. Remember mad seam. Multiply, add. When you're multiplying terms of the exponents, you add the exponents. There's your answer. 2 over n 6. Actually, what I can do is, this is another thing you can do if you're writing on your computer. You can take a picture of your work, or snippet tool. Use the snippet tool and paste. You could do that as well. All right, last one. All right, so a couple things you want to look at. Actually, let me. All right, changed up the pictures a little bit here. So, last one, how to deal with this and where to start. These problems do get a little, I don't want to say complicated, but you definitely want to, it takes a little bit to get used to where to start. Okay. My suggestion would be deal with parentheses first. So when we think of our rules, that's the exponent to an exponent. Then deal with negative or zero exponents, and then do the first rules we learned. So I'm kind of working backwards, really. So let's take care of this right here first. So remembering our rule from the previous video, exponent to an exponent, you multiply. So let's keep the top the same. And then on the bottom, we're going to take that 4 and we're going to take it times negative 3. So negative 12. And then v to the 0, 4 times 0 is 0. So this will stay 0. All right. Now, let's deal with 0 and negative exponents. So I'm going to come down here. So 2 is going to stay. And then if we have a negative exponent, it crosses the line. We don't want any negativity. We only want positivity. You're going to go sit on the other side to become more positive. So v to the third is going to go here. And v to the negative 12th will become positive when we move it up to the top. So v to the 12th, that v stays on top, this v right here. And then v to the 0 is 1. So I'm not even going to write it because v to the third times 1 is still v to the third. Let's combine where we can. So let's deal with the top first. 2 stays. And on top you have 12. Don't forget that has a 1. So there are actually 13 v's. 3 on the bottom. And then, so that was right there. That rule was, if we're thinking mad seam, multiply. You're adding the exponents. And now let's do division. You're subtracting. So 13 minus 3 is